So in this video today, we're going to go over graphing logarithmic functions. So first, what I want to do is talk to you about how graphing an exponential function is related to graphing a logarithmic function. So we're going to first go ahead and graph this. So to do that, we're going to go to Desmos, and we're going to put this equation in there, and we're going to go ahead and find our table. So I went ahead and put this function in there, and you can see it here. It looks like this. And so what we're going to do is we're going to go ahead and pull our table from this. And these are the values that we're going to put in our table, and then we're going to graph it. Okay, so those values that we had were, when we put -2 in for x, we got 4, because, again, that would be, it would flip it, basically. So when we do -1, again, to the -1 power, that would flip it again, so it would be 2 to the first. And then when we do 0, anything to the 0 power, obviously, is 1. When we take it to the first power, obviously that's 1/2. And then when we take it to the second power, we're going to square the top and the bottom, and it's going to give us 1/4 or 0.25. So we could say this is 1/2 or 0.5. This is 1/4 or 0.25, okay? So let's go ahead and plot those. So at -2, we're at 4 there. At -1, we're at 2. And at 0, we're at 1. At 1, we were at 1/2. And at 2, we were at 0.25. So this is what our graph of 1/2, sorry, kind of crooked down there, to the x power looks like. Okay, so that's our exponential function. Now, when we talk about the log, we're going to talk about the inverse. Okay, so we're going to write this first as this would be y is equal to 1/2 to the x power, right? So as we go through the log of this, we're going to actually write it a different way. So we're going to say x equals 1/2 to the y power. Why? Because when we write that as a log now, we're going to say our base is our base, right? So this is going to be log. Actually, let's do this in blue. So I'm going to say the log of, what's our base? 1/2 of x, remember, we're going to do what's on the other side of the equal sign, equals what? Y, okay? So now we're going to take this function, we're going to put it in Desmos, and we're going to see what the values are for it. And it should be the inverse of this. So all of these points should flip, okay? And you're going to see that they actually do. So first I want to show you where you can find this log from. So we're going to go over here to functions again, and we're going to scroll down. And we're going to find, see, that's the log base 10, right? But this is log with a base. So we're going to use this. And so we're going to put log of 1/2, right? Oops, well, why did it do it like that? Let's see if we can do it. Let's put a parenthesis down here where this is. Let me try that again. So log, go back here to log, and back up here, sorry. Log, so we want to put 1/2 here. So I'm going to put parenthesis and see if it'll, nope, won't let me do it that way. We can just put 0.5 down there, guys. So 0.5, there we go. I'm going to go back and get rid of this inside parentheses. And so then we had log base 1/2 of x, right? Okay, so this is this function, okay? So notice that it does look like the function we had. So I went ahead and put in 1/2 to the x power. And so this blue one right here, or purple, whatever color that is, that was our original function, right? Okay, so that's the original one we put in. And then this is the log of 1/2, log base 1/2 to the x power, right? So now what I want to do is get the table for this. And we're going to then see, notice that these values are undefined over here. And the reason they are is because this graph is never going to go left of the y-axis. And why is that? That's because that is going to be our asymptote when we're talking about logs, okay? So what I'm going to put in here are some of those values we had before, like 0.25, and see what we get when we do that. And then I'm going to put 0.5. So I'm going to put 0.5 in here. 0.5, right? And then we're just going to keep going with our 1 and then our 2. And I'm going to go ahead and put 4 in here and see where that takes us as well. So 4. Okay, so these are now all values that we're going to see a relationship with pretty quick when we put them in the table. Okay, so now notice we're going to put 0.25 here, and we did that. We got 2, right? We put 0.5, and that was 1. And we put 1, and that was 0. When we put 2, that was -1, and we put 4, and that was -2. So hopefully you can see that these are all inverses of each other. If we look at 2 down here, it's 0.25, and we got 0.25 and 2. So they are switching, just like we expected. So now let's go ahead and graph this, and let's see what we get. So if we're at 0.25, that would be at 2 right here. So that's like really close, right? Then we're at at 0.5. Whoa. Yeah, 0.5 would be 1, and then we're at 1, 0 right there, and then at 2 we were at -1, and at 4 we were at -2. So this graph is going to look like this, basically. And what you should be able to see very clearly here is that this is reflecting over the line y equals x, right? And that's what we expected, that they are inverses of each other, okay? Now, the reason we're talking about this is because we're going to use some of our rules of exponents to go ahead and solve parts of these problems, okay? So, in example 2, it says, using the graph, state the domain and range, find any intercepts, zeros, intervals of increase, decrease, asymptotes, and end behavior. So the first thing we're going to do is our parent function, which is f of x is equal to the log of x. So when we talk about an asymptote, that's the line the graph approaches but never actually touches. So our asymptote is right here. This time, this is going to be what? Before it was y equals 0. So now this is going to be x equals 0, right? We expect that because it's an inverse, right? Now our intercepts. We're asking, where does this graph intercept the y-axis? Well, this one does not ever intercept the y-axis. Okay, so this has none when it comes to intercepts. And when I show you this, when we look at it in a minute, in Desmos, you'll see what I'm talking about there. And then we got this 0 right here. See it right there? That's where it's crossing the x-axis, and that would be 1. Okay. X equals 1. Now I want to show you guys how to solve these mathematically. So when we're talking about an intercept, we're talking about when y is equal to 0. So we're going to say y is equal to the log of x. So we're going to change this into an exponential. What I need you guys to remember is that when there is no base, there is a base of 10. So now we're going to change it to an exponential. So this is 10 to the 0 equals x. So what would that be? What is 10 to the 0? What's anything to the 0? That's 1, right? So that's why our X-intercept, or sorry, our X-intercept is 1. Okay, now we're going to do the Y-intercept. And this time when we do that, we're going to say y equals log, again, of what? 0. Okay, so we're just plugging 0 in now for this one. So now if you do the log of 0 in your calculator, you're going to get an error message, okay? So why is that? Because there is no intercept, a y-intercept, okay? So now I want to show you guys this in Desmos. So here again, we're going to go over to functions. We're going to go down. This time we're just going to use our log, and we're going to put of x, right? So there's our equation. That's what it looks like, okay? And notice right here we have our intercept. And also you're going to see if we do our table function like we have normally been doing, if we look at any values, including 0, it's undefined. And the reason for that is that the graph will never go to the left of the y-axis, okay? So all our values, if you look at this graph of x, are going to be greater than 0, right? Okay? So let's go back and let's talk about all of that. So when we look at our domain's going to be, x is going to be what? Greater than 0, right? Now our range is going to be all real numbers, isn't it? Okay, so remember that. Our range is going to be all real numbers because that graph is going to be going down forever and it's going to be going to the right forever, okay? Now, intervals of increase or decrease. So when we look at our intervals, we're looking at what's happening to this graph. Is it not rising and going to the right the whole way? It is, okay? So it's going to be increasing the whole way. Now, where is it increasing from? Now, remember, this time it does not include 0. So we're going to say it's increasing from 0 to infinity, and we're going to use parentheses because we're not including that 0 number. Now, as we talk about end behaviors, as we go left, look at where the graph, we have that asymptote. So as x approaches 0, what's happening to our f of x? Yes, it's going down, okay? And as we go right on this graph, which would be infinity, right? What's happening to the graph? Yes, it's going towards positive infinity. And I want to bring something to your attention. When you guys are talking about end behaviors here, your f of x for these are always going to be negative infinity and infinity. It just depends on the order, okay, depending on the type of equation it is, right? So here's our next one, and this one says, using the graph again, state the domain of range, list of transformations, find all the intercepts, zeros, intervals of increase, decrease, asymptotes, and end behaviors, okay? So we're going to start with transformations here. Now, what I want to bring to you guys' attention is that once again, we're going to talk about our log, and we're going to have an a out front here, and we're going to have a bx minus h, right? Okay? Plus k. So what do a and b mean? A is a reflection over the x-axis. B is a reflection over the y-axis. The h is a movement left or right. And the k is a movement up or down. So let's talk about what we have right here. So if we have a plus 4 here, it's really going to be a minus 4, right? So it means we're going to move 4 to the left, because there's a minus up there in the equation. And here, this is going to be what? 1 up, okay? So if we look back at our original parent graph here, you should be able to very clearly see that this graph was right there on the y-axis, right? So what happened to it? It moved 4 to the left and it moved 2 up. You see that? Or 1 up, sorry. So now we're going to talk about our asymptote. This time our asymptote is over here, right? So our asymptote is going to be what? This time it's going to be x is equal to negative 4. And that means our asymptote is connected to our h, okay? Now we have the intercept already on here. That's where it intersects the y-axis, and we have the 0 already. So your intercept's right there, and that's where it intercepts the y-axis. We could get that from Desmos, but I want to show you guys how to solve for this like we did on the last one. Okay, so let's just look at this intercept first. So when we're looking for the intercept, we want to put y equals, and we're going to put 0 in for our x, okay? So when we do that, that's going to be, sorry about that, the log of 0 plus 4 plus 1. I can't write today, guys. Okay, so we're going to do the log of 4, and then we're going to add 1 to that. So when on your calculator, when you do the log of 4, what you should have got was 0.602, right? So 0.602, and then we're going to add 1 to that. So y is equal to, ry is equal to 1.602, which is exactly what we have right there, right? So we're going to say 0, comma, 1.602. All right, now let's talk about our x-intercept, which is our 0 of our function. It's right there, right? Okay, so we're going to solve for that one too, and that by doing for that one, we're going to say 0 equals, and then we're going to put, again, our equation, and I'm going to show you guys how to do this one. Okay, so this is going to be log of x plus 4 plus 1. So the first thing I'm going to do is move that 1 to the other side. So this is going to be minus 1 equals log of x plus 4. Now, what I need to remind you guys is that when there is no base, the base is 10. So now we're going to put a 10 here because there was no base, and then we're going to use that. We're going to put it back in exponential form. So this is going to be 10 to the negative 1 equals x plus 4. Well, what is 10 to the negative 1? It's 1 over 10, right? So this is going to be 1 over 10 is equal to x plus 4. Then we're going to subtract 4 from both sides. So that's going to give us negative 3.9 equals x. And isn't that the value we had right here? It is. So even if you don't have a calculator, you can find the x-intercept and the y, the 0, which is the x-intercept, and the y-intercept by doing what we just did, okay? All right, so now our domain, let's look at this. Our domain, x is going to be what? Greater than negative 4, because again, it's going to approach that asymptote, but it's never going to touch it. Our range is going to be all real numbers. Again, this is another increasing graph. Where does it increase from? Look at your x values, okay? It increased from, what, negative 4, doesn't include that, on to infinity, right? Now let's talk about our end behaviors. As we go right on this graph, that's infinity, right? Where's the graph headed? Yes, towards infinity. Now, as we head left, what are we going to intersect as we head left, though, at that negative 4, right? So again, we're always going to have the asymptote in this statement, if there is an asymptote. And then as f of x approaches that negative, or as x approaches negative 4, this f of x is going down then, right? Okay? All right. Now let's see if you guys can do this. You try and come back to me when you're done, okay? All right, so here again, we have some transformations, right? So we're going to move 2 left. That's what this is telling us, 2 left. And then this right here is telling us is we're moving 4 up, right? Okay, our asymptote is right here. It is that vertical line that the graph's going to approach but never touch. So what is that? X is equal to -2, right? Then our intercepts, again, we're going to, in our 0, we're going to go ahead and solve for these, okay? So to solve for our intercept again, we're going to solve for y. So y is equal to, again, the log of 0 plus 2 plus 4. So we're going to do the log of 2, and then we're going to add 4 to that. So when we do the log of 2, I got y is equal to 0.301, and we're going to add that to 4 to that. So our intercept here is going to be 0, 4.301. Okay, that's our intercept. Now we want to talk about our 0. Okay, so our 0, we're going to put 0 in for y and solve for x. So this is going to be the log of x plus 2 plus 4. So we're going to subtract that 4 again. So we're going to be -4 equals log of x plus 2. Now remember, we got a base down here of 10. Again, remember that? So if there's no base there, we give it the base of 10. So we're going to take 10 to the -4th, and that's going to be equal to x plus 2. So here again, we're going to do, this is going to be 1 over 1, 2, 3, 4. That's a really little number, y'all. Because we moved that decimal place 4 places left, so we put 4 zeros on there and move it to the bottom, right? And then that's equal to x plus 2. So we're going to subtract 2. So this is going to be -1.9999. And that's going to be equal to x, okay? So if we were to actually come up with this answer, it's pretty much -2, y'all, okay? So x is equal to -1.9999 if we actually write out the answer. But it's really close, guys, to -2, all right? So then let's talk about our domain and range again. A domain is going to be what? X is going to be greater than, this time, our -2, because that's where our asymptote is. Our range is going to be all real numbers. This is still going to have an interval of increase, right? And what can we say about where it's increasing from? From -2, again, our asymptote onto infinity, right? So our end behaviors, as x approaches infinity, that means we're going right here. Where's the graph headed? Towards infinity. And as x approaches our -2, that's our asymptote, we're going to head towards negative infinity because the graph is going down, right? All right. So here's our next example. Let me go through this one with you guys. Now, the difference with this one is we got a negative out front. So when we start talking about our transformations, we're going to talk about a reflection over the x-axis. Now let's talk about what comes next, because I think it's important. So notice that we have a negative under there. So I'm going to factor out a -1, and that's going to leave me x minus 3. Well, that's going to affect what comes after when we talk about left to right. Okay, so that negative is going to tell us it's a reflection over the y-axis. Then that -3 tells us we're moving 3 right. Remember, it's always opposite of what we think, right? And the -1 is going to tell us it's 1 down, okay? So those are our transformations. And if we go back and look at our original graph, I'll go back here to our parent graph, this one right here, notice that's exactly what happened. It flipped and flipped, okay? So as we look at this graph, it's going to become relevant. So our asymptote, I already drew it, is what our graph is going to approach. So this is going to be x equals 3, and that makes sense because that's a positive 3 up there, remember, because that's minus h. So now, hopefully you can see this intercept right here, but we don't know what it is, so we're going to solve for it. So we're going to say y is equal to the negative log of, and we're going to do a -0 plus 3, and then -1. So obviously there's no such thing as a -0, so we're going to say y is equal to negative log of, that's going to be 3 minus 1. Okay, so that would be negative 0.4771 minus 1. So y is going to be equal to negative 1.4771. So that's our intercept. So that's 0, comma, negative 1.4771. Going to verify that in a minute with decimals, okay? And now we want to find the 0 of the function by putting 0 in for y and solving for x, okay? So that's what we're going to do next. So we're going to say 0 equals the negative log of negative x plus 3 minus 1, okay? So the first thing we're going to do is add 1 to both sides. That's going to be 1 is equal to negative log that negative x plus 3. And to get rid of that negative in front of that log, we're going to go ahead and multiply this whole thing by negative 1. So that means we're going to multiply this by negative 1, okay? So that gives us negative 1 here equals, actually, let me just keep that in red. So that's going to be negative 1 equals log of our negative x plus 3. Remember, our base here, when we don't have a base, is 10. So we're going to go ahead and put that here. And now we're going to put it in exponential form. So that's going to be 10 to the negative 1 is equal to negative x plus 3. So anything to the negative 1 power is going to take it to the denominator, right? So this is going to be, again, our 1 over 10 is equal to negative x plus 3. So we're going to subtract 3 from both sides. So let's go ahead and do that. So that's going to be 1/10 minus 3, which is equal to negative x. So that's going to give us negative 2.9. And that's equal to negative x. So which means our x is actually positive. X equals 2.9. Now I want to go ahead and look at this on decimals, okay? So let's go ahead and put that up here first. So x is equal to 2.9. And we're going to look at this in decimals now. So I'm going to go to my function here, and actually I'm going to put a negative first before I do that because it's a negative log. So we're going to scroll down here to our log again, and we're going to do minus x plus 3. Was it minus? Yeah, minus x plus 3. Plus 3, and then we're going to go outside of there, and we're going to do our minus 1. Okay, so notice that does look like the graph that we had. And now we can double check and make sure that we got our zeros right. We got negative 1.4771. Yep, that's what we got. And over here we got 2.9. So that's a good way to verify and make sure that when we solved it, we got them correct if we have access to decimals. So our domain this time is going to be x is going to be less than 3, right? Because all of our x values are to the left of that asymptote. Our range is still all real numbers. This time, again, our graph is increasing. This time, where's it increasing from, though? From negative infinity, which is out here, right, to where? Our asymptote, which is our 3, right? So that's what we're going to put in there. So now when we talk about end behaviors, we're talking about as x approaches. Actually, this one right here should be as x approaches 3, right? What is happening to our y values? They're going up towards infinity, right? And then as we go towards negative infinity, which is over here, where's the graph headed? It's headed towards negative infinity. Just keep in mind that these end behaviors are always going to be infinity and negative infinity depending on which direction it ends. It might be flipped from what it is here, but it's going to always be one of those two. All right, so here's our year try. Go ahead and do this and come back to me when you're done. So here again, this is a reflection over the x-axis. Can't type right today, right? Then this plus 4 is going to be 4 left. And this minus 3 is going to be 3 down. Okay, our asymptote's right here. We can see where it is. It's a vertical asymptote, right? So that's going to be x is equal to negative 4, and that's because we're moving 4 to the left. Once again, we're going to solve for our intercepts, okay? So we're going to solve our intercept and our 0. So we're going to say y is equal to the negative log of 0 plus 4 minus 3. So we're going to actually do the negative log of 4 and then minus 3 from that. So that would be the log of 4 is 0.6021. And obviously that's going to be negative. We're going to subtract a 3 from that. So this is going to be y is equal to negative 3.6021. So our intercept is going to be 0, comma, negative 3.6021. And that's right there. And it kind of looks like it's about there, right? Okay, now we're going to solve for our 0 of our functions. We're going to put 0 in for y. And so it's going to be minus log again. And this time we're going to do our x plus 4 and our minus 3. So we're going to add 3 to both sides. That's going to be 3 is equal to negative log again of x plus 4, right? So we're going to multiply both sides by negative 1. So that's going to get us a negative 3 there. So that's going to be negative 3. Sorry, that was supposed to be a negative 1, y'all. I don't know why I put a negative 3 there. It was supposed to be a negative 1 times, okay? So that's going to give us a negative 3 is equal to now the log of x plus 4. Remembering again that our base is 10 here when we don't have a base. So this is going to be 10 to the negative 3 is equal to x plus 4 when we put it in exponential form. Now, 10 to the negative 3 is basically 1 over 1,000, right? 1 over 1,000. And that's equal to x plus 4. So then we're going to do minus 4 plus 1 over 1,000. And so that's going to be negative 3.999, right? So x is going to be equal to negative 3.999. So our 0 of our function is going to be negative 3.999, which is pretty close to 4, and it kind of looks like it's at 4 out here, doesn't it? Right there, okay? So now, let's talk about domain and range. So domain, again, what's happening to our x values? Our x values are going to be greater than negative 4. Our range is going to be all real numbers. This time, this graph was decreasing, isn't it? And where's it decreasing from? From our negative 4 onto infinity. And then now let's talk about our end behaviors. As we head right on this graph, that's towards infinity. The graph is headed towards negative infinity, isn't it? And as we head left, which would be what? As x heads towards our negative 4, that's our asymptote. It's always going to be part of this. So now we're headed towards infinity. Okay?